Hey everyone, welcome back to the lab. In this video, we're going to be going over how I improved the performance of an F# and Giraffe web server by 6.5x. First, we're going to start talking about some web benchmarks, what they are, and some things to think about when you're looking at them. Then we're going to go into F# and Giraffe and dive into kind of the performance issues and what the change was to actually hit that 6.5x improvement. And then we're going to finish off with some performance takeaways. So what can you learn from this whole thing and bring back to your own systems with respect to performance? So let's start off with web benchmarks. So benchmarks basically try to run simulated workloads on systems to better understand how they perform in quote unquote the real world. Now web benchmarks do this, but they're usually running against web servers. But there's all sorts of different benchmarks for things like libraries or different technologies, for different algorithms, data structures, you name it, there's probably a benchmark out there. And the usefulness of these benchmarks is that they try to create a set of unified comparable metrics so that we can understand how different technologies that attempt to do the same thing compare against each other in whatever that their use case is. So in the domain of web servers or web benchmarks, often this is going to be around how many requests per second can it handle, what is the kind of median latency that server can respond in, even under high load, and then how many times does it error out, especially at high load. If it's something that errors a lot, then maybe something you need to worry about with respect to your reliability. Now there's a lot of different web benchmarks out there, but the main two and the ones that we'll be looking at today are the Tech and Power benchmark and then the Benchmarker benchmark. There are many others, but these tend to be the more popular ones and the ones that tend to get updated more frequently. If you want to take a look at those, there's a link here, and also will be one in the description. So benchmarks are great for comparison, but the problem is that it's often hard to actually find a good benchmark. And the main reason for that is because it's actually kind of hard to build a good benchmark. And so here I'm going to go through a few reasons why this is hard and why we need to kind of be a little bit wary about these results, because this will set the foundation for the rest of this performance talk. So the first big thing that makes benchmarks hard is that it's often hard to define what a normal use case is. What is a normal workload for a given technology? Well, we know that you usually will have a certain reason that it was created, but often the uses of this technology will vary widely by the needs of whatever organization or developer or stack actually puts it into their workflow. And so you can see how if you are measuring it in one respect under one kind of workflow, but an org doesn't actually care about that kind of workflow, but a different workflow, that the results may or may not actually mean anything for them. The second big part is that, let's say that we even were able to find a good workflow that kind of matches what everyone's trying to use this thing for. Well, now we have to look at it from the technology standpoint, where technologies will typically have a wide array of different strengths and weaknesses. So one, for instance, might be very good at being very performant and have high throughput, but it might also be very bad in actually developer experience. And so now we have a ton of different workloads that we might need to try to actually capture this data, and now we might need to have a ton of different metrics to actually capture all the different strengths and weaknesses that we care about, which is hard. And so both of these things take, a lot of work. And then we get to number 3, where there's not so much incentive to put the work in to make these comparisons really good. And so often when we see these benchmarks, they're going to be run by some sort of company that has some stake in performance. Maybe they do consulting or something. Maybe they are run by, a developer and a few of their friends on the side. But typically there's not going to be like a big corporation that is backing this up and really trying to make these benchmarks like as precise and good as possible. And so typically we don't get the full breadth of workloads and different kinds of metrics we would need to really understand each of these comparisons. And then this is actually exacerbated by the fourth reason this is hard, and that is because where a lot of the effort and money typically is going into is usually from the creators of frameworks, the creators of technologies, to make their thing better in the benchmark. And this makes sense because if you're building a framework, you want a lot more usage. If you're building a company and your image is built on something, you want to make sure that it looks really good. And so when we see a lot of updates, that's usually not to the benchmark itself, it's usually to improving or optimizing the thing that is being benchmarked, often to the point where it no longer resembles what a normal instance of this would look like in the wild. And thus, even if we got all of the other things pretty correct, now this kind of leads to imprecision because we're not even testing the thing that you would probably be using. So all this to say that it is really hard to actually build a good benchmark. Now there's a lot more reasons, there's a lot more examples of this, but that's kind of outside the scope of the talk. And so if you're interested in more about this, like dark patterns that you see that aren't quite cheating, but maybe aren't like useful, I really like this blog post from Dustin Morris, who's the creator of Giraffe, which I'll have linked here and in the below if you want to read more. So now that we kind of understand what benchmarks are, how to use them, and some of the maybe dark side of benchmarks, let's dive into F# and Giraffe and kind of the performance issue that brought us here today. So first off, F# and Giraffe, it's my basically first pick for building any kind of web API. I really like F# and Giraffe for its ergonomics. It gives you all the functional paradigms, has pretty good support with libraries and stuff, and a ton of other reasons why I think its DevX is just among the best. And then both of these are built directly onto ASP.NET, which is basically Microsoft's standard for web servers, so it gets a lot of speed and a lot of support. Now diving more into these technology choices is again out of scope of this video, but if you want to learn more, and especially see kind of what a simple web API looks like, check out this video where I dive into building a simple web API with F# and Giraffe. So now we understand F# and Giraffe, let's go over into the performance. So the first thing to say is that Giraffe is pretty fast, and a lot of this is because it's built on .NET again, but it itself is pretty fast and does some interesting things to make it stand out in some of these benchmarks. And so if we look at the Tech and Power benchmark specifically, we see that it comes in 21st in Fortune's for full web frameworks. So this is broken down a little bit, and we won't go into those, but if you want to look into kind of the different options, the different ways that Tech and Power benchmarks these things, you can go to the link here and then check them out. So I'm telling you it's fast, but this thing looks like it's near the bottom of the results. So in order to show you just how fast, we kind of have to show you the biggest or the full list of results. And now this is a lot. I don't really have a good way to show you a vertical thing, so I just kind of put it sideways. And I've tried to mark here where Giraffe is, and we can see it's like towards the top. And it's 21st out of over 100 different frameworks, which makes it pretty good. Definitely in the top 20%. Even if we say that some of these frameworks near the end maybe are just not supported anymore and not worth benchmarking. So that's my proof that Giraffe is fast, which brings us to the problem. So, is Giraffe slow? As we talked about, many benchmarks do different kinds of things. They're not the same. And so in this particular benchmark, which is the benchmarker one, which I'll have a link to here at the bottom, we actually see that Giraffe and Giraffe endpoints are near the bottom. They're pretty slow. And I've narrowed it down to just F#, but if you looked at it with respect to other languages, it'd be down there around Python. And we expect a lot more from these frameworks that are built on .NET. We expect them to be a lot faster. What's even weirder about this result is that we can see here a framework called Saturn, which I know is built on top of Giraffe, is actually much faster than Giraffe is performing here. And so we're seeing Giraffe is about 66% slower than Saturn, which is a framework built on top of Giraffe, which is a very odd result. Usually when you build on top of something, you're going to have to incur some sort of overhead, and that overhead is probably going to make whatever the newly built thing is a little bit slower. And so even if Giraffe were a little bit slower than Saturn, maybe we could say that they made some optimizations or something. If it was like within a 10-15% range, maybe it's just random noise. But 3x or 66% decrease is pretty sizable, and so that kind of signals that something's weird here. So how do we fix this? Well, to kind of understand what's going on, to actually even understand what problem we need to solve, we kind of have to just dig into the code, because again, all these web frameworks are different, all of these benchmarkers are different, and we really got to understand what's actually running to do this. So that's what I did. The benchmarker repo is fully public. Most of these are as well, and that's because usually it's going to be not the benchmark maintainers that are updating all these web frameworks, but actually people who care about the web framework, who want to see how they compare to each other, that are keeping these things updated and making sure that they actually look like a real server. And so here, basically this repo is kind of set out like a bunch of folders for every programming language it's going to run, and then within those folders, it's going to have a new folder for every single framework that it wants to benchmark. So I dove into the F# version, I kind of looked around at how all these other servers were built, and that's kind of how I come up with this fix. So here's the fix, coming directly from this PR linked at the bottom. And basically what it's doing here is it's configuring the .NET web server via this function configure logging, and what we're doing here is calling log.clearProviders. And so basically what it does is just removes logging from the framework. We're like, hey, run your server, but don't log anything. And what are the results of removing logging? Well, we actually see Giraffe endpoints and Giraffe getting over 100,000 requests per second, where previously it was in the teens or 30s. And this represents a 6.5x improvement in requests per second for that Giraffe endpoints benchmark. We can kind of sanity check this, that it is a bit faster than Saturn, within about 10%, which makes sense just due to overhead. But I think it's useful to also just think about like why did this work and what we can learn from it. So why did this actually work? Well, we removed logging, and we know that logging is kind of expensive because it incurs I/O, which I/O is itself expensive. And then if we actually think about the scenarios that these benchmarks are running, they're usually doing a ton of different requests, but the actual process running on the server is usually extremely light. It's extremely small. Usually it's just going to return some text, and it's not going to do anything else besides that. So even if logging is, not such a hard, expensive process, if we put it in respect to the actual process that needs to run for these benchmarks, it's actually very expensive in comparison. And so this tiny overhead really adds up when we are basically doing no work on the server besides this. And so you might be like, well, should we just remove logging, from my own server? And I definitely want to tell you, don't do that. Logging is way more important usually than the performance it eats up. This is how we basically get visibility into all of our running apps, how we know that the thing's performing the way it's performing, if something went wrong, what went wrong. And so this is like way more valuable than whatever small percent you could probably save on this logging. Things that will make this even a smaller of a win for you is that, real world processes are probably going to do a lot more things, whether it's like accessing a database for stuff or doing some sort of in-memory calculations, something like that. So even just the ratio of how much work is going to logging versus actual processing is going to be much different than we see in these benchmarks, which again just goes to show how not representative of the real world they are. So what can we learn from this, change and kind of performance issue? Well, I still think there's a few things we can learn, even if it's not, remove all logging. So the first thing that I think we can take away from this is that we should use benchmarks, but we should use them with caution. And so these are very useful comparison tools, especially to get a really great understanding of an entire landscape. We probably can't dive into every tool or technology ourselves, so this gives us a really good idea of where to start and what things we should actually spend more time looking into. But the caveat here is that these comparisons are really only as good as their real-world integrity, and as we kind of talked about earlier, there's a ton of different factors that are basically working against the integrity of these benchmarks and the usefulness then of the metrics that we are comparing with. And so as you go to approach and use benchmarks for your own technology decisions, for your own org, for your own company, my recommendations are to always take a look at the code and try to understand, at least at a surface level, like, what is this benchmark actually doing? What are these things that it's actually testing? How do they actually do their work? And then when you see outliers from this, it's really important to really look into them. Because there's a good chance that the reason that they're outlying, whether for better or worse, is maybe not their actual performance, but it's actually the test itself that is causing them to have such weird results. And if not, if it is actually their performance, then that is actually a really good data point too for understanding either how you can avoid that thing if it's bad, or to take it over to your own framework to make it that much better. Now, my second takeaway is that you should still be aware of your logging. So as we talked about, I don't think you should just remove logging altogether. It's way too important for that. But I would hazard to guess that probably your logging is not super optimized. And so while the opportunity here is not going to be 6.5x, it's probably not even going to be 2x, there's a good chance that it will have some percentage points on there. And that's pretty reasonable. And so my recommendations for this are really to just, keep an eye on what you're actually logging. Are you seeing a lot of things that you're logging that don't really seem essential, aren't really used for things? Then it might be really good to just cut those out. That's less load on your server overall, and that can be an overhead boost for every process hitting your server. And then if you just really need all this data, if you really need all this stuff, a last result can always be to sample. A lot of times when we log, we don't necessarily need a very specific log. What we're actually doing is trying to get, again, an understanding of the landscape. And so sampling here can usually give you pretty good precision and often lead to a lot of cost optimizations, both in the performance of your server, but also maybe in the money required for storing these logs downstream, of actually analyzing them in queries after the fact, things like that. And the final thing I want to leave you with here is that different speeds matter differently. And so when I'm talking about performance, I'm often talking about the speed of web servers or code to complete their task. But for most organizations, for most use cases, this performance is actually not a bottleneck, or at least is not the largest bottleneck, and therefore not the opportunity with the highest leverage. For most organizations, really the things that are going to lever themselves to be better is probably first money and profit. The second, especially for systems, is the time to change or experiment or iterate. And then probably the third one is going to be reliability or maintainability. So how much effort is being spent on just keeping the thing alive or actually improving it. These two things I think are typically going to be a bottleneck in more organizations, and also a larger bottleneck in organizations with multiple of these. So while looking at performance can be fun, it can be useful to tweak your servers and stuff, it can definitely save money. I would definitely recommend to just understand your domain first, so you can actually better prioritize and understand how important that is for your use case. And then once you really understand it, then you can focus on impact. So if it happens to be performance, great. Go ahead and tweak your logging. Go ahead and add caches, everything like that. But if it's more likely like time to experiment or something, maybe it's important to go the other way, where you really focus on DevX and a little bit less on these tweaks. If you're interested in seeing more about how I build and deploy all of my apps, you can check out this video, which gets you up and running with Cloud Seed, my F# and Svelte kit boilerplate. And if you have any questions about F# or Giraffe or these performance benchmarks, let me know. I've been digging through the code a lot recently, so I'd be happy to look into something. And this is where you can find me. I think that's it for me. Thanks for watching, and I'll see you in the next one.